Here is a lesson about finding the equations of tangents and normals to curves. So before we get into that, we need to reconfirm a few basics. The first one is to remind yourself from GCSE that if two lines are perpendicular to each other, then the gradient of one of those lines will be -1 divided by the gradient of the other. So because a normal is the line which is perpendicular to the tangent, later on we're going to see that if I can work out the equation of the tangent, I can easily get the equation of the normal by doing -1 divided by the tangent gradient. Second part is that fundamentally we are finding equations of straight lines here, albeit that those straight lines are tangents or normals. So basically we're heading for an equation of the form y equals mx plus c, where you'll remember that m is the gradient and c is the y-axis intercept. So if we take this as our example, y equals x squared plus 5x minus 7, it's going to cross the y-axis at -7. Ignore the line in blue at the moment, that's the one that we're heading towards. So you've got an idea of what this graph is going to look like. It's going to look something like that. It's a quadratic, so its shape will be a parabola. And we're looking for the tangent, so in other words, a line which just clips the graph where x is 1. Okay, so x is 1 would be somewhere around there on this graph, and we're looking to find the equation of this blue line. So if we keep our work structured and organised here, we can see it's quite straightforward really. The equation of the graph is x squared plus 5x minus 7. So if I differentiate that, the equation of the gradient of the graph will be 2x plus 5. We're working at the point where x is 1. So if x is 1, I put x is 1 into the y equation and I find out that y is worth -1. So the coordinates of this point here are 1 minus 1. And if x is 1, I can put 1 into the gradient equation and find that the gradient at that point there is dy by dx equals 7. So now we have reduced this problem simply down to a straight line problem. Okay. All we're asking for is, can we find the equation of a line which passes through 1 minus 1 with gradient 7? And we know that the equation of a line is mx plus c. And we know that in this case the gradient is 7, so its y is 7x plus c. And we know that it goes through the point 1 minus 1, so we know that if x is 1, it must make y equal to -1. So substitute those values into the equation, we can work out what the c is, and there's the equation of our tangent. And that makes sense on our sketch, because if the parabola crosses at -7, a pretty steep tangent line crossing the y-axis at -8 looks about right. And if you plot this on a graph drawing calculator, you'll see that it does just clip the parabola once. To find the equation of a normal, which is a line at 90 degrees to the curve, we do almost exactly the same thing. So in this case, I've changed my equation to y is x squared minus 9, and I want to find the equation of the normal when x is 2. So x squared minus 9 is going to be a parabola that looks something like that, crossing at -9, and y will be 0 when x is -3 or +3. I'm trying to find the equation of the normal when x is 2. So if the parabola crosses the y-axis at 3, x is 2 is going to be somewhere about there. And a normal to that graph will be the straight line which meets the graph at 90 degrees. So I follow exactly the same process, keeping myself organised. The y equation is x squared minus 9, so the dy by dx equation will be 2x. I need to evaluate both of these equations at the point where x is 2. So put x is 2 into the y equation, and I find that y is -5. Put x is 2 into the dy by dx equation, and I find that at this point the gradient is 4. So in other words, at this point here, where x is 2, y is minus 5, and the steepness of the red graph here is 1 across and 4 up. Now at the start of this lesson we reminded ourselves that perpendicular gradients are, each gradient is minus 1 divided by the other gradient. So now I've reduced this problem down to a straight line problem, because my normal equation is simply the equation of a straight line which passes through 2 minus 5 with gradient minus 1 over 4, because it's perpendicular to the tangent gradient. Same as before, the normal is basically just a straight line, so y equals mx plus c. We know what m is, and we know that when x is 2, it must make y into minus 5. Substitute those into the equation, work out c. There's the equation of our normal. Minus a quarter x minus 4.5. Just have a look. Does that make sense? Yes, it would be a negative gradient, and that looks about right. And if you plotted it more accurately on a GDC, it would show you